In this video, let's revisit the concept of functions. I'm going to cover two different types of functions, the built-in functions and user-defined functions. We will also cover the concept of how we can create our functions a lot more flexible. We can use args and kwargs. Let's first understand the types of functions in Python. We have built-in functions, which are functions available in the Python library itself. Any programmer can make use of these functions to write their programs. We have already seen some of the built-in functions. We have seen dir function, which is used to find all the attributes and methods associated with a specific type of object. We also saw help function, which was used to find a small document on a specific function. We also saw the use of sum, min, and max functions to find sum, minimum, and maximum from a sequence of numbers. We can also make use of this divmod function, which can provide division and modulus of two operands. It provides a tuple with two elements. The first one will be the division output and the second one will be the modulus output. In Python, we also have the functionality to check if the object is of specific type. We have seen the use of type function, which was used to get the type of an object. We can use isinstance function to verify whether an object is of specific class. There are also few built-in functions which can be used to program in a functional style. This is a totally different programming style and we will cover them in a separate video lesson. There are built-in functions map, filter, and reduce, which can be used to write programs in a functional programming style. We also have user-defined functions. These are the functions defined by the user or the programmer in order to make the code reusable. This also helps modularize their code to maintain it easily. Here is a simple user-defined function. We just use the def keyword and we write the body of the function. Let's learn all of this in code. Here, if I have numbers list with elements 1, 2, 3, and 4, now if I want to find all the attributes and methods associated with this list, then I can use the dir function, dir numbers, and it will give me all the associated attributes and methods with this list. We have seen some of these methods already in our list videos. We have seen clear, count, insert, append, and remove methods. If the object was of different type, then it would provide the attributes and methods associated with that specific object. In this case, I have this string variable, and if I check dir course, then it returns all the methods and attributes associated with this string data type. You can see some of these methods: capitalize, index, is alphanumeric, count. Some of these methods we have already seen in our string video. So this dir function is useful when we want to get all the attributes and methods. Similarly, in Python we have abs function, which can be used to get the absolute value of a number. If I have a variable with value -10 and if I check abs of this number, then it will simply return the positive number for that specific negative number. If the number was already positive, then it will not do anything. Now the beauty of this function is that it can work on different data types. If I have any number with a floating point value and if I check absolute value of this, then also it's going to work nice. There is all function which can sometimes be useful. This can be used to verify if all the numbers in a sequence are truthy. Let me show you an example. If I have numbers list with elements 1, 2 and 3, and now if I check all numbers, then it returns true. If one of these values was falsy, let's say I add 0 into it, and now if I check all numbers, then it returns false. This is because one of the element does not satisfy the condition in all function. If I have any value which is falsy, then it will return false. The opposite of this is any function. If I check this on this numbers list, then it will return true, because at least one element is truthy. If all the elements were falsy, let's say 0, none, and let's say empty string, and now if I check any of this list, then it returns false. We also spoke about divmod function. Let's see that. If I try divmod of 10 and 2, this will calculate the integer division of 10 divided by 2, which will be 5, and the modulus of 10 divided by 2 is going to be 0. So it returns 5 and 0. If I modify this numerator to let's say 11, in this case it will return the division operation output as 5, but it will also have the modulus output as 1. We can use isinstance method to verify if an object is of specific type. Let's say I have a variable name with value Victoria. Now if I check isinstance this name variable, whether this name variable is of type string, it returns true. We have also seen the use of sum, min and max. Let's verify them again to make sure. I have this numbers list with elements 1, 2 and 3. If I try sum of numbers, it returns 6. If I type min of numbers, it returns 1. And if I type max of numbers, then it returns 3. If I want to find document on a specific function, I can use the built-in function help sum, and it returns this small document string for this sum function. Now if I want to define my own function, I can use the user-defined functions. Let's define our own function to find if a number is prime. This function is going to take a number which we want to check if it is prime or not. Prime numbers are the numbers which are divisible by 1 or the number itself. In order to find this, we can iterate through all the numbers between 2 and the number itself, and if any of those numbers is able to divide this number fully, that means this number is not a prime number. So to implement that, I am going to iterate through range 2 up to this number. And in each iteration, I am going to check if this number is divisible by this index. If we find the first occurrence of any number which can divide this number fully, that means this number is not a prime number, and we return false. If we loop through all the numbers and still we are not able to find any number like that, then it's a prime number. In that case, we return true. Let's verify this function by checking it against a prime number, let's say 19. It returns true. 19 is a prime number. If I check this function against a number which is not a prime, 8, then it returns false. Let's understand how we can make our functions more reusable. We can use args, which provides a convenient way to pass multiple arguments to a function. We can pass multiple arguments in a function, and those will be available inside a function in the form of a tuple. We can write it like this. Here I have this product function which is taking this star args variable. The variable number of arguments are passed using this single star. And if I print this args variable, then it prints all the arguments that we pass in the form of a tuple. Here I am passing 1, 2 and 3. And this function call will return 1, 2 and 3 in a tuple. If I pass 2 arguments, then it prints a tuple with 2 elements. Now similar to this, we also have kwargs. These are also known as keyword arguments or kwargs. This allows for multiple keyword arguments in a function. These are usually written as 2 stars, and we write them using kwargs variable name. This variable name does not have to be kwargs, you can name it whatever you want, but in Python community it's a convention to write them as kwargs. These are usually written using 2 stars. When we print these keyword arguments, it simply prints a dictionary containing all the keyword arguments. For example, here in this case I am calling this hello function with 2 keyword arguments, name and greet. And if I print these keyword arguments, it prints this dictionary. If I pass only one keyword argument, then it contains only one key value pair. Let's understand them a little more in a code. Let's say I want to define a function that can take as many arguments as I want. Let's say I'm defining a summation function, and I want this summation function to have as many arguments as the user wants to pass. If the user wants to pass a single argument, then he can pass one argument. If he passes 3 arguments, then this function should return the summation of all those 3 numbers. In order to achieve this, I can use the args variable. Args variable are written using this single star, and inside this function, if I try to print this args variable, then it will simply print a tuple. Let's call this function with 2 elements, 2 and 3. Let's execute this, and it prints this 2 element tuple. If I call this same function with, let's say, 4 elements, then it will print a tuple containing all 4 elements. This way we can make use of this args variable in order to calculate the sum of all the numbers. Inside this function, we can simply iterate through all the elements of this args variable. Let's define a local variable sum with an initial value of 0, and now I can iterate through all the elements of this args variable and add it to this sum variable. Finally, I can return this sum variable. Now, if I call this summation function with 2 elements, then it prints the sum of those 2 numbers. But if I call this function with, let's say, 3 elements, then also it can print the sum of all those 3 elements. This is a very useful feature. In order to calculate sum of 3 numbers, we don't need to write another function with 3 arguments. We can simply use the single function and use all the arguments that are passed by the user. Similarly, we can make use of kwargs to get all the keyword arguments passed by the user. Let's define a sample function that shows the functionality of this quarks variable. These keyword arguments are passed using two stars. Inside this function, if I print this quarks variable, then it can simply print the dictionary containing all the elements of this function call. If I call this function, let's say with two elements, name equals Andrew and age equals 22. If I call this function, it will simply print this quarks variable. Let's see what we get. It prints a dictionary with elements name and age. These are the keyword arguments we had passed in this function call. We can make use of these keyword arguments inside the function by first iterating through all the key and value. For key value in kwargs.items, now we have access to all the key and the value. I can simply print them like this. Here you can see both the keyword arguments. So this way we can make our functions more flexible and allow users to provide multiple arguments to the function. In this video, we covered different types of functions and we covered the concepts of args and kwargs to make our functions more flexible.